everyone, welcome back to the REST API in-depth course. I'm super excited about this video. In this video, we're going to go over routing on the server in Deno together. So we've so far seen a bit of how kind of requests and responses work. We've looked at protocols. We've even built our own simple server in the previous video. What we're really missing is an ability to kind of route the different requests very similar to what we'd expect kind of a regular web server to do, where if I go to /users, I go to a specific set of resources or web pages and responses, or if I go to /login or logout or posts and things like that, we can direct the user to different parts of our application and have different types of responses depending on which route you're actually using. So in order to do this, we need to actually learn how to do routing on our backend. Now, this is something that traditionally is done with a lot of libraries, and there's just so many different solutions out there. In fact, popular frameworks, for example, in JavaScript ecosystem, things like Express or Koa, and in other ecosystems like Python, there's like Fast API and things like this. They have all their own routing frameworks kind of built in. We're going to do this totally from scratch in Deno, just using regular JavaScript, regular TypeScript, as well as the web standards, and see kind of how you would come up with something like that on your own. And we'll actually see that it's actually not that bad. So I'm super excited to get this. Let's take a look together as how we can actually get our routing working for the first time on our servers. All right, so to start, I just want to kind of give a bit more of an overview on exactly how this is going to work, just to set the stage for what we're going to be doing in this video together. So for routing, we want to conditionally route the requests that are coming in to our servers and be able to do something different, some different type of logic on our backend, in this case in Deno, in TypeScript or JavaScript, depending on what route that user was requesting or that client was requesting at that time. So for example, if we're asking for /login, we might want to do something different than if the user is asking for /tweets, for example, or /posts or something like that, right? So different responses for different requests. And another thing that's going to be really awesome is we're going to be able to split up our server code kind of depending on the routes. So we could have like a set of authentication and authorization routes, which we'll see in later videos towards the end of the series. And those would go to a specific part of our app, and we can actually focus on the code and write functions specifically for that without having to have everything in one really, really big file. So we can kind of have like if you think of it like a traffic conductor or like a plane signal, I forget what they're called, controller person with the little wavy flags and the cool lighty things in their hands. We can say kind of go this way if you have this question, or that way if you're looking for this resource, or this way if you're looking for something else. So let's take a look at how you might even achieve this and the different kind of methods that are traditionally used. And we'll go through each of these one at a time as well as examples. So for example, imagine that a request comes in. The thing that we're probably going to want to route on is the request URL. Right. So if it's like localhost and then the port and then /something and that something changes, we can catch that and we can do something else depending on what that URL is. So traditionally, probably the most obvious thing that we might want to do is something like an if statement, right? Which kind of makes sense. It's basically saying if the URL, for example, is /users, then go to the user's stuff. Like do all the users related things. But if it's not, then go somewhere else. Or we can have an else if, and we can have a whole bunch of these chained together. We can say like if users, go here, else if animals, go there, else if profile, go here, and we can just have as many of these as we want. And then eventually maybe the else would be like a not found or like some kind of error page or something like that. Now, we've seen this before, right? We've worked with several different things in JavaScript where we have a lot of if-else statements and we want to basically pick one of them for a certain scenario. So we have this nice function in JavaScript called a switch, or an operator, I should say, which allows us to, very similar to how like a train track would kind of switch depending on which direction you want to go on. We can switch depending on that request URL. So that makes the syntax a little bit easier. It's less kind of brackets all over the place, and it's kind of easier to read top down, but it's effectively just a glorified if else statement anyway. So we'll see a bit of that as well. Now, The next thing that you probably would think of is, maybe we can use like regex for this, right? Regular expressions to actually solve this problem. And that is absolutely something that a lot of frameworks do. Now, regex is very, it's a very hairy tool in the sense that it can do a lot of very, very powerful things, but it's a bit scary to use in the sense that first of all, creating the expressions and making sure that they don't accidentally catch things that we don't want, it was going to require a lot of testing and debugging. For example, maybe we think of a regex for a particular route, and we think it's doing the user route, but maybe it's doing like anything that has a user in it, and we actually catch other routes that we might not want. So we have to be very careful with how we structure the regex. But we'll see an example of this, at least a simple example, and I'll give you some kind of gotchas that we have to be aware of. Now, what we're going to be focusing on for most of this course, and what I want to show you last, but not least at all by any means, is actually a web standard API called the URLPattern API. Now, this is something that's probably way less known than it should be. I'm not sure why. It's definitely a bit newer. I guess that might be one of the reasons. But this is something that is, if you've ever used a lot of the web frameworks out there, like the ones I mentioned earlier, you're probably used to having some kind of nice convenience functions. For example, how can I pull out an ID from the URL, or how can I pull out a name and give things different names and groups and different URL structures. And we'll see examples of all of this. But that is a very, very powerful tool that's actually built on those same concepts that a lot of the frameworks use, but it's actually built in as a web standard, at least for most browsers at the time of this recording. It's also built into Deno in this case. So I would love to show that to you, and we'll look a bit on MDN and how that works, and we'll save that one for last, and we'll see some cool examples with that as well. So let's start at the very beginning kind of this journey so we can kind of build up to that idea, and we can all be on the same page together. So we'll code this in a second, but I just want to start with this. Now, we saw how we could create a handler. So I just have the handler function here. You can imagine I have like Deno serve like below this, and we'll actually code this, and so you'll see how it works. But I kind of want to focus on kind of what's happening here. So here we have an async handler function, and we get in our request right here. And we're going to turn this, the URL from that request, which is that entire string, which is like HTTP. So it has the protocol or the scheme. It has the subdomain, the domain, the top level domain, the port. It has everything in there, including the actual path name and any query parameters. It's all built in, but it's just one long string. So one thing that is nice to do is to be able to actually pass this into this URL constructor in the URL API, which again is a web standard API. So we can actually pull out the different composite parts of this URL thing. So in this case, for example, we can grab a path name out of it, which is everything after the top level domain and the port at the very end after the slash. So in this case, for example, this would be like localhost and then the port like 9000 or 8000 / rar in this case, right? And we could easily kind of make an if statement in this case based on what the user is, or the client in this case, is actually asking for. So if they go to localhost / rar, we would be able to give them a response with this emoji. And if they go to localhost / woof, we'd be able to give them a response for this emoji. And then in all other cases, kind of like a not found in this case, we'd respond with a different emoji, right? Now, I'd like you to think for a second, like what might be some challenges with this approach? Just like right off the bat, if you were to think of like what might be some things you'd run into, what are some issues that we might come up as we go through this? So think about that, and I'll pull up VS Code. And what I'll do is I'll start a new Deno project. So I'm going to do Command-Shift-P or Control-Shift-P here, and I'll type Deno up here, and I'm going to grab the Deno initialize workspace configuration, which should be the first one that pops up for you. If this doesn't pop up for whatever reason, that means you might not have the extension installed, or you need to just reload VS Code. So we covered that in the previous videos. I'm going to say Deno enable linting yes, and unstable APIs. We're always going to pretty much, or most of the time, I'm going to press no for this, and that's going to create this VS Code directory. You're going to see Deno is set up in my workspace, and then we have our settings.json with this data in it, which we just entered in that little prompt that popped up. So now what we can do is we can create our server. I'll create a new file here, and I'll call a server, and I'll just do this up because we're going to be creating many servers in this case. I'll just give it a little tag here. I'll say server-conditional.ts. Okay, and We'll start by doing our Deno serve. So I'll say Deno.serve, and I'll give it a, you know what, let's just go to default port in this case. So you can see the default port is 8000. We'll just go with that for this particular set of examples, just so I don't have to type as much with the actual port number. And I'll give it a handler there. And I'll say async function handler. And our async function handler is going to have, I'll just hide my terminal for a second. This is going to be a request object. So we can type it like this. So this is REQ coming in for short for request, and it's going to be the request object. And we can do something with this. So in here, I'm going to say const URL. I'm going to create a new URL object from this request.url parameter out of this actual request object. So this is coming to us from the client. And Deno is going to give this request object to us. And in there, this is the web standard request object. We can grab the URL as one of the different things in there. There's things like body in there and many other things that we'll see in other videos. So now what we can do is we can say if this URL dot, and we can see now we can grab stuff off this because of TypeScript, which is quite nice. Pathname, which is everything after the slash, after the port and the top level domain, is equal to, for example, let's do meow. We can do something in this case. So in this case, we always have to return a new response. And I can return a string in this case, and I'll just add an emoji. I'll put a, let's do a lion right there. Lions, I guess, go meow. Do they go meow? Let's go with that. Otherwise, in this case, technically I don't need an else, but I'll just add this so we can add more else ifs in a second. We'll return a new response, and I'll say not found, and I'll add a, I think it was the Deno. Not sure why Deno is not found. I love the Deno, but we'll go with the Deno, and we'll leave that as our else there. So notice that also, if I don't have this else here for a second, notice that TypeScript is complaining to me here. So if I hover over this, it's basically saying, let me bring that up again. It's saying that it can't, there's no matching overload for this. And if we eventually read through this is kind of a lot of gibberish looking stuff. But if you read through this, what this is effectively saying to us is that I should probably bring this part back in here because this is actually an error. And let me just move this down. This is what happens when I have my formatting. It's still going to give us that error. So what's happening is that we only are returning a response in the case where the path name is meow. So in all other cases, if you think about this, what this code is doing is actually doing a return undefined, right? And this is not good. Like we have to return a response to the client. Otherwise, it's just going to hang there for the client, and they're going to be expecting for a kind of callback or a response, and we're not going to be returning anything. So we would always want to return something in every single case that's a response object, and in this case, we'll just return not found in all other cases. So every single case has to return a response object in this case, and we are doing that in this case with the else. So I'm going to start the server here. I'm going to pull up my terminal here, make sure I'm in the right folder, and I am. And I'll say Deno run, and I'll say -- allow -net for the permissions, for the network permissions here for Deno. And I'll say server -conditional.ts, and I'll press enter. And now I'm listening on that port, 8000, you can see right there. It prints it out automatically for us. I'll switch over to Chrome. I'll create a new tab, and I'll just quickly grab this. I'll Control-C, and I'll Control-V that in. And if I make that really big, what we can see is, let me pull up my inspector in my terminal as well. With the network tab, I get a not found. So if I refresh this and I open up this network tab, and then I go to localhost, we can see that we indeed get back a 200 OK, because we haven't changed that, and that's the default response status code, because everything went okay. We didn't say that technically it's not okay. We probably should change that response status code if we are really doing like a proper not found. But we can see that this is actually working correctly, right? So in this case, we're going to 8000/, which is not one of the if statements that we made. We only made it for meow. And we have a not found. So let's see if we do /meow here. I'm gonna do /meow. And we still get a not found. I think I know why here. I actually just saw it when I switched over here. This is just meow, not /meow. And so I'm going to add that here to be /meow. And the problem is I didn't actually start Deno in watch mode. So I have to actually turn off the server and then restart the server. So I'll change it to watch mode for the future examples. But if I do that and I reload the page, what we should see now is our little cute little, is that a tiger lion? Very, very adorable. I like that emoji. And if we see that we pull up the request headers here, this is a request URL is meow. So just to show you exactly what's happening here, I want to console log out the request.url as well as the URL here. Okay, and I do have to restart the server here, so I'll do watch mode, I promise, for the next one, so we have to keep watching me restart the server. But I'll redo this request here, and I'll switch back here. And if I scroll up, what we'll see is this right here is the request URL, which is exactly what we expect. And we pass that into this URL object so that we can pull out the different requisite parts here, which is what this is. I'm getting 2 logs because of the favicon here in this case. And that's making a separate request, as we saw in the network tab. But we can see here that path name, if I kind of scroll down a bit, is this one right here, and that's what we're checking on. So we're pulling that out. We're checking to see if it's /meow. And if I change this, let me just clear this terminal. If I change this to meow2, we get not found. And if I switch back to my terminal here, you can see that this is now meow2. So we're not in the if statement, and we're going down here. Okay, so hopefully that one makes sense. I'll close this server, clear it out just so that we can start with the next example shortly. So try that out. I encourage you to try different else ifs and things like that, just like I have in here, but you can imagine how that would just keep checking each one of these one at a time. And you need quite a lot of these to support quite a large amount of paths if you did end up using this route, no pun intended. So the next one I want to show you is switch. So this one's actually not really much of a change. It's actually the same thing. It's just using the switch keyword and a little bit of niceness over like the syntaxiness of all this. So let me show you what I mean. I'll create another file here, and I'll just call this server-switch.ts. And I'll do the same thing here. I'll say deno.serve, and I'll call my handler, and I'll do my async. I encourage you to type all this out instead of copying and pasting as well, just so you get a lot of practice with this, because it is very useful and important to kind of have that muscle memory. So this is going to get a request object. Const URL equals a new URL, and we're going to pass in the request object URL field that we get, and that's going to make our nice URL object. So now what we can do is we can switch on that URL.pathname, and we can have our cases. So for example, case which is going to be /meow, and that is going to be this code right here, which is going to be return new response, and we're going to do our we'll do our lion. Where's my line? There. It's hard to find. And I'll do a few here. I'll do case /woof, slightly different. And I'll do return new response, and this will be our dog. I wonder if is there a wolf? Let's see. Is there a wolf? Oh, let's do a wolf. That kind of looks like a horse to me. Maybe my eyes are just not working right now. And then we'll do the default case, and that's going to be return new response, and we'll have our little Deno there. There we go. And I'll leave out the not found text. Okay, so. Note that I'm not using break here because I have the return keyword for all these, so that's effectively breaking out, and every single case here is covered. So if I don't have the default here, you can see that again, very nice. TypeScript in this case is yelling at me because it knows that it needs to have every single case covered for a response object, and in this case, if I comment that back in, we indeed do get that error going away, which is pretty beautiful. So this is really useful for TypeScript on the back end specifically. So I'll bring up my terminal here. I'll do deno run --. I'm probably not going to restart this too many times. I'll do allow -net, and I'll do --watch. Why not? And I'll say server-switch.ts. And there we go, it's on 8,000. And if I go back to my terminal here and I refresh the page, we'll see that I get the not found is gone because we don't have that anymore. It's just our Deno there. And if I go just to meow and I press enter there, we get my line. And if I go to /woof, we do get the the wolf. I want to show you this in Insomnia really quick as well, just so we can see how this would work. So I'm going to pull up Insomnia. I'll go to create a new collection, or I'll just use my existing collection, in this case, REST API in depth. You can create a new collection, pure request collection, and give it a name if you like. And in here, I'll do I'll click the plus button. I'll do a new HTTP request, and I'll just rename this one to, let's do routing, and I'll rename it. And I will grab this URL here, and I'll switch to Insomnia. Okay, so we can test a few here. So I'll do woof, and I'll send that off. And you see down here, we indeed get back. It's pretty tiny, but I think you can see. I don't know why it's so small. You can see I get back that little emoji here, and then if I do woof2, I'll get back the Deno, and if I do meow, I'll get back the cat. So that's quite nice. And these are all GET requests. In this case, for example, if I do a post request, we're not distinguishing behind the method yet, right? So we're not doing like a switch on the method, which would be eventually something we would want to do, because these are all returning the same thing. It's just checking the path name and totally ignoring the method. But that's something that we want to eventually fix, and we'll start learning those methods together in future videos. Okay, so that's switch. So you can see that's quite nice. Like which one's better? This one. Pretty much the same thing. There's not too much of a difference between these. You could probably refactor this to make it a bit easier to read and things like that. But these both have a lot of challenges associated with them. So let's take a look at another option together. I'll stop that server. I'll switch over back to my slides here, and I'll show you regex, short for regular expressions. Now, this is probably what most people would reach for when they're trying to kind of do their own routing from scratch. In fact, a lot of the most popular routing libraries, as I mentioned, do kind of use some form of this or a combination of this and other things behind the scenes. So regex allows us to search a string for a particular pattern, and we can get pretty creative with very complicated types of searches. I would encourage you probably to have a video on the channel, I think in the JavaScript series, where we look at regex, at least a very simple version of regex, specifically in JavaScript, and we can see how that all works. But another way you can actually look at this, there's a really nice site, hopefully it stays online, Regex 101. And if you just go to this website, regex101.com, I have a lot of respect for the people that created this. You can kind of zoom in, and you can create different expressions here for testing whether something exists in something else. So just to show you a really quick example, for example, if I have like a slash meow, and in this case, I would have to escape the slash. If I have like down here, local host, hopefully you can, let me zoom in a little bit more on that, local host, colon, 8000 / rar is there's no match / meow. You can see that suddenly does match. That's a match. It has a group and the position and everything. And if I do meow 22222, you can see there is a match. It's just at this position right here. And if I don't have the full meow in this case, you can see that it is not there. But we can do really fancy things, right? Like we can do like we can say like there can be like a digit and there can be like I think like one. What is exactly here? I think it's like one or more, match a single character, digit, something like that. I always forget what these are, to be completely honest. Down here in the bottom right is all of the ones that you'd ever really want to know. So is it like, I think you got to do like D plus. I just can't, honestly. I'm like totally blanking off the top of my head. You can see me totally flop and fail at this stuff. The digit one, if I scroll down, so you can't see me. I'm showing you this here, right over here, in the very bottom right. Let's see. We have general tokens, common tokens. Any non-digit, any digit is /D. That was a mistake. So /D. So we can see that if we can, I think we can also do this. We can say like one or more. That's kind of what I was looking for right there. So that's going to match like all this stuff together. So meow plus any number of digits, and plus in this case is a quantifier, which is saying, I think it's one or more. Is what plus is. You can't see it here. My face is covering it, but if you open up this website and try to kind of do this along with me, you can see that there's a plus and it says one or more of that thing, in this case of a digit. So Yeah, that's a bit of regex. I don't want to go too deep into that, but you can see that you can make some quite complicated things. There's like almost an infinite amount of things that you could search for with regex. And I'll just show you one example of how you would do this, and we'll actually use kind of an API on top of this to make it a bit easier for us, and that's the URLPattern API. But I want to build up to that, so let's see how this actually works. So in this case, we have our handler again. We're going to create a new URL object out of that, and we're going to match the path name. So strings in JavaScript have a match method, and that match method allows us to test a regex expression. So if I go to Google here and I search string match JavaScript, you can probably eventually end up at Mozilla's developer documentation string prototype match. And if I open that one up, let me just zoom in here. We can see a match method string retrieves the result of matching a string against a regular expression. So they have some examples here very similar to what we just looked at together. And you can just pass it a regular expression, which can be either a string in this case or a actual regex literal with the / inside of it, which is I think what they use right here. So yeah, I encourage you to try out different things in here and play around with it to see how it works. But we'll just see a really simple example to start. The example that we're going to look at is very similar to what we just looked at together, but we can actually end up eventually building some pretty complex patterns on top of this. We can search for different sections and match and groups, which we'll actually see a nice higher level API after this on how that works. So let's build this one out together. We're going to match on that rar, and then depending on what that match is going to do, we're going to go send that response, and yeah, that's pretty much exactly how it works. I think there's a is it LMNOP T? Oh no, test is from the other one. So in this case, there's match and then there's match all, which deal with the string specifically from the string prototype. How to do matches, and you can also create regular expressions separately using the actual regex constructor, but I'm not going to go into that because we're going to be using URLPattern. So that was a lot of me yapping. I just wanted to show you that there's quite a lot behind the regex here, and if you're interested in how that all works, definitely take a look at the actual API to see how that works, or check out one of the videos I have on this channel. So let me come back here and I'll create a new file here. I'll do server-regex.ts. And I'll do the same thing here. I'll do deno.serve. I'll do handler. And then here we'll have our async function handler. And I will do a request object request. We're probably wondering, please, Nader, why are you not copying and pasting? I have a strong rule, no copying and pasting, because you don't learn and get muscle memory that way. I encourage you to try that as well. Okay. So we have this URL, and as we saw here in the slides, I'm just going to do if in this case, but this could very well be like you could use pretty much any of the other methods to like a switch in this case. Or actually, in this case, you actually have to use if, because we're doing true and false values. So we can only do true, and then if that's true, and then if that's true, and then the order in this case is going to matter, which is another kind of potential issue that we'll have to deal with in the future. So we're going to check to see if it matches, the path name matches our regex expression, and this can either be a string literal or the actual regex literal itself. So if I come in here, I'll say if the URL's path name, remember, which is the part after the slash, dot match, we're not going to use match on. Let me just close this terminal for a second, dot match. And if I hover over this, you can see that match can take a regular expression string or a regular expression literal object. So in here, I'll just do a string method, which is /meow, and then we will do a return a new response, which is going to be our tiger. And I'll just do an else if url.pathname.match, and I'll do /rar. Rar and meow, and now I'm getting confused with myself. So response. What says rar? Is it like I don't know. Let's go with tiger. I'm not. This is really confusing. That's not. Is it a bear? Maybe a bear. Does a bear go rar? I guess so. You can skewer me in the comments below with how I can't do rar and meow separately. I get confused. Otherwise, we'll return a new response. And in this one, let's just do a scared face if there's nothing there. So we're going to check the path name with a regular expression, and we're going to be able to match based on that. So this is actually the same thing as, let me just show you like a regular expression literal, just so you can see how that works. This was rar. So that is effectively the same thing as like matching on /rar, right? This is just using the regular expression literal syntax in this case instead of the string. So you can actually use both. So I'll show you that in a second. So let me start the server here. So I'll do Deno run --allow -net --watch, and then I'll do server -regex.ts, and then I'll have my port 8000 here. I'll switch back to my Chrome for a second, and I'll do woof. I get my screamy emoji because that's not one of the options that we have. And if I do rar, I get my bear. So that's pretty nice. So that's matching this response right here. And then the last one that we have is meow, which is going to get our lion or tiger, I guess lion there. And then that's meow. So that's pretty nice. So you can imagine if I do that here, I'm going to get the same response. And this is rar, and I should get. There we go. I didn't send it off. That was my bear. And then I'll do moo. And I don't get a cow. I get my scary face because we don't have that option in our server right now. So that's pretty much routing for all those three options, right? We saw switch, we saw conditionals, and we saw regex. Now I want to show you what I've been building up to for this entire video and what I'm most excited about to show you, which is the URLPattern API. Now you're probably thinking, this is probably the most flexible, and you'd be right about that. A lot of libraries do use this behind the scenes, but using this vanilla raw like this is a little bit challenging. There's a lot of things that can go wrong. You can imagine that kind of sitting here and trying to craft all these very crafty, no pun intended, regexes, and then if you want to change even a little thing in there, you have to test it and make sure that it matches perfectly and doesn't match other routes and things like that. It can get kind of complicated pretty quickly, and then doing the manual grouping is a bit of a pain. So there is this beautiful thing that is an API that's web standard built into most browsers at least, or most engines, and I'll show you exactly what I mean in a second. And that is the URLPattern API. So check this out. Let's kind of walk through this slowly because we're going to be using this a lot throughout this course, and this is going to be very, very powerful and allows us to do some pretty much unlocks everything very similar to what you'd expect from any kind of routing library anyways. So we're going to create our URL, and we're going to create patterns, okay, using this URLPattern API, which has a constructor, and we can pass it an object. And we can pass it the kind of requisite parts of the URL that we want to match against. So most of the time we want to match against the path name. So let's do that to start and see how that works. So in this case, I have one pattern for the path name rar, and another path name for the for the path name woof, or another pattern for the path name woof. So what we can then do is we can take that and we can call test on it to see if it matches. So for example, here I'm saying, does the URL, this URL that's coming from the request object, is it matching against the rar pattern that we have? Which means, like, does it match the /rar path name? If it does, then great. We can return that response, and we can kind of do that for all of these. So the only really difference here is we're creating these objects, which are these URL patterns, and we're using test instead of kind of like for regex, we were using match, and over here we were just using either the cases or we were using the equality operator directly. So it seems like this is kind of just more code, right? Like we're not really making things easier here. We're kind of actually making things harder because we have a whole bunch of these that we have to build. And then we have to make it one for each of these things. So let's build this out, and then I'll show you kind of some of the power behind this shortly. So I'll switch to VS Code. I'll create a new file. Super excited for this one. Server dash, and I'll call this pattern.ts. And I'll just close this server for a second and close that. And I'll do deno.serve. And this is going to be our handler. I should probably change that name at some point, but we'll just go with that async function handler. We're going to get a request object, and we're going to be able to do our thing in here. So const URL is equal to a new URL of that request.url. And then what we can do is create our patterns. So I'm going to create our patterns for our routing. And I'm going to say const like rar pattern. is equal to a new URL pattern. And this is an API, is a web standard. I'll pull up the docs in a second, but if I hover over this, we can see that the URLPattern API provides a web platform primitive for matching URLs based on a convenient pattern syntax. And we can have a whole bunch of cool stuff in here as to how that works with some examples, but these are all going to be in the docs anyways. So in here, we can pass in the input and some other things. I'm going to pass in an object, and I'm going to pass in pathname like this. How do I know this? Because I looked at the docs and I've used it a bit. So we'll look at it together and I'll show you kind of what I mean. In this case, I'll do /rar, and I'll do another one for /meow. So const meow pattern is equal to a new URL pattern. And be careful, this is not a new URL. This is URL pattern, which is a different API. And this pathname I want to match against /meow. All right, so the way that we actually match these is if the rar pattern, in this case, dot test this is where I always get confused with the match that we saw earlier. If test is going to test if a given input matches the stored pattern, and this is going to give us a Boolean value, so that's why we can put it in a conditional statement, and we can get true or false back depending on if that pattern matches the URL that we pass it. And in this case, it's matching on the path name. So if I pass in the URL here, it's going to take this URL, it's going to take the path name, and it's going to match it against this pattern right here and see if they match. So if it does in this case, we're going to return a new response object. And here we're going to have our, let's say our lion, and else if, let's do a meow pattern dot test and the URL. That means that we're in the meow case. So we're going to return a new response. And this is going to be, let's do a cat, there we go, a smiley cat. Although technically, I guess, I don't know, does this animal lion also do, I don't know, all very confusing. Else return a new response, and this is basically our default case where everything else is not there. Let's return a let's do a facepalm. If you don't get anything, then you get a facepalm back. Okay, so we're matching against rar and meow in this case, and that's going to be the pathname parameter, and then we can get basically one of these three responses depending on if it's found or not. So let me come here, and I'm going to do Deno run --watch --allow -net, and then it's just server -pattern.ts. Now if I go back to Chrome, I'll go to my localhost meow, and I'll refresh that. I get back the cat, which is quite nice. I'll go to rar, and I get back my my line, and then I go to I'll go to moo, and I get my facepalm, and this is going to work here too, right? If I do send here, I get my facepalm. If I do meow, and then it doesn't matter as the method, right? I can do a patch, and then I can say rar, and then I'm going to get my line, and then I can do meow, and I'll get my cat. I don't know why I had to do it twice there. Interesting. So yeah, there we go. That's pretty useful. So you're probably thinking, looking at this, I'll just close this terminal for a second. Probably thinking, looking at this, that, you know, this is like a lot of work compared to like even just like this, right? Look at the code difference, or like switch, or even just a regex before was much easier, right? So let me show you something really, really awesome. Check this out. I'm going to show you this URL pattern, an example of how we can do custom routes. Now, I forgot to mention here actually that this is all based on something called the path to Regex library, which is actually what things like Express and many other routing libraries actually use behind the scenes. So this is we have a lot of that power manually for us to actually use ourselves. So check this out. Imagine that our path name looks something like this. I want you to focus your attention on this part right here that I have highlighted. This is something that you would see in pretty much most web frameworks, things like some Python ones or Rust ones, or like Express and Koa and things like that. You would see things like this for a router. We want to be able to match everything against a /animal in this case, and we want to grab a group for the /after animal and actually use that as a named kind of parameter or named value in our code. So we're saying that please match against anything that's /animal /something, but then that something, I want you to give it back to me and call it like name, so I can access it as name. So check this out. If we do this as the path name, Okay, and this is using that regex to what was it called? Path to regex library, and you can look it on GitHub, and that's what most of these libraries use behind the scenes. We can do test on it, right? And that's going to test to see if it matches, which we just saw. However, check this out. This is the part that's new. We can actually execute that pattern, execute the regex to get the groupings on that URL. And that's going to pass out those groups to us. You remember if I go back here to my regex 101 and I kind of come back here, you can see that I have a match, and this is like there's different groups. And if you scroll down in here, you can see that there's these things called group constructs, and you can put regular brackets around things. And that's kind of what it's doing for us automatically behind the scenes, just so you know a bit of how that works. So if I, switching around too much here, if I switch back here, we're saying please match and give me the grouping so I can actually pull it out. And check this out. Here we're grabbing the path name groups.name. Name is coming from this name right here. And that's exactly what we asked it to do. Give me the name if it exists, which is why we have the optional chaining here. If matches is not null in this case, then grab back the group name in this case. And there could be multiple groups, right? We could have multiple different name parameters, and there's a whole bunch of really cool stuff we can see in here, which I'll show you right at the end of this after we test this out together. So let me come back in here, and I'll add to my rar path. Let me add something here. I'll say rar slash, and then actually, you know what? I'll add a new path in here. I'll say const animal pattern is equal to a new URL pattern. And in this case, I'll say path name, and I want to match slash animal, and then slash, and then the name of the animal. And I can put whatever I want in here. I can put like the ID of the animal. I can put like the type. I can put slash ID. I can make a whole bunch of these if I want to. Okay, and what it'll do is it'll match on that, and it'll actually give me that as part of the group name. So I'll go with what I have as an example, and I'll leave you to test this out yourself, and we'll do some of the exercises together as well. So in this case, I have a new route for slash animal slash something. I'll do another else if clause here. I'll say else if animal pattern dot test on the URL. So in this particular case of it matching the animal pattern, we know that we have groups on this, right? So we saw here that for our groups, we can execute that pattern match on that URL to get those groups out of it. And this is only going to be in the case of this particular route where we have these kind of groups set up. That's what's doing behind the scenes, is creating the regex and putting the brackets around us for us automatically, so we can focus on actually a higher level API like this. So I'll say const matches is equal to animal pattern dot exec, and I'll show you where I got these from by looking at docs in a second, but I just don't want to scare you by looking at docs right away. I like to look at examples in the code very quickly first. Matches a given input against the stored pattern. It can be absolute URL, or it has the relative URL. In this case, we're passing in, I think, the whole object. So you can see some examples here of how that actually works. The documentation has a whole bunch of these as well. So in this case, we're just passing in the URL object, which has everything split up nicely for us automatically. And we'll get back this matches object, which has all these groups on it. So let's take a look at this. So I'll say exec this on the URL, and then we'll say const, and I'll say animal name is equal to matches. And then we don't know if this exists yet, so I'll just optionally chain it, and we would probably want more error handling on this in the future. Dot pathname dot groups dot in this case name. Okay, which is coming from here. And this part here is the only part that's not really like checking the types, because this is coming from kind of right here. So this is kind of one of the limitations of like just using TypeScript. So we have to be a bit careful in this case, because it can't really exactly check that name exists. But that we won't go too down that path for now to start. So then we want to return a new response. And this is going to return with the animal name. And animal name is going to be either a string or undefined in this case. So we would just return nothing. We could probably return not found, for example, like not found as a string if animal name doesn't exist, something like that, right? We could put that in different places. So yeah, so that's pretty much it. So we're pulling out the animal name out of the URL. So let's test this out. If I switch back here, you can see that it did restart my server, which is quite nice. If I come back up here and I test this, I go to /animal/ let's just do monkey. You can see that I get monkey back, right? I'm getting the name that I typed in here as this parameter back, like echoed back to me. If I say panda, I get back panda. Right? And if I just go to /animal/ nothing, that's not matched, so I go to the not found route. So if I do animal / moo, I will get back that string, and that's matching on this route right here. And I guess in this case, I can't really test this not found. I wonder if I can test it if I do like no, I think a number will still count like this. No, and that's actually not going to match at all because that's a different route. I would still get back that because it still matches technically. I wasn't specific enough with the requirements for that regular expressions. So in this case, we can see that this is quite powerful, right? Like this is something that we can use everywhere. Because now we can actually build at a high level. A lot of APIs work something like this. We would do something like router .get or something, and then we would say /animal/ name. This is like something that we would get, and then we would say we would probably pass it, the function that we want to do stuff with, something like that. Depends on what API you're using or what language you're using, but usually we would tell the router or the application that we're using the route name, and this part right here is the part that we're working on, which is the actual routing part. And then we would pass that to the code that we want to run, which we could abstract this all out into a function later if we wanted to, or put this part into a function. And that's exactly what's happening right here. So these are all built on top of each other, and we're doing everything from scratch. But you can quickly start to see, hopefully, that this is a very powerful API. I want to show this to you really quick on MDN as well. So if I go to URLPattern API MDN, there's, I think, two here. So there's URLPattern API. I'll just go to URLPattern API to start. You can see that this is an experimental technology. We'll go to the browser compatibility table down here really quick. So right here on the right side, if I click browser compatibility, you can see that this is supported in Chrome, Edge, not Firefox, Opera, not Safari, and all these different browsers. And we'd have to, if we were trying to target some of these other browsers on the front end, we would have to use something different, or actually use something to translate it or transpile it to using like Babel or something, so that we can go down to ES6 or ES5 that is recognizable by some of these technologies. But you can see right here on the very end, we have Deno, which is pretty cool. You can see it's under the server section, and it does support this API as of this version. And there are some things in here that it might not support. So I encourage you to read through these. This is something really, really important, very similar to a web page called Can I Use? And I encourage you to take a look at that. So I highly encourage you for fun to kind of take a quick glance through here, look at the examples that they have and some of the complex patterns you can make. You can see even here that we can do some really cool stuff. We can have wildcards. We have the name groups. That was what we saw. We can have like other types of capturing groups and use complex regular expressions in here. You can see that we could use it in all sorts of cool different cases and start to really make some fancy regular expressions and actually start to capture pretty much all the routes that our application might need to use. And we could probably separate these out into functions eventually and actually start working on them independently and make our app a bit easier to follow through as we come back to it as a developer or try to debug things. So there you have it. That's the URLPattern API. We're going to be using this quite a lot, and it's nice to be able to build up to this. So you saw the if statements, you saw switch, you saw regex, and then we saw URLPattern, which is what we're going to be using. And it relies on regex and some of these other things behind the scenes. Super, super powerful, and it's going to allow us to actually make these complex routes much easier. We still have to be a bit careful with how we do things, but it is a super fun and powerful tool. So I hope you enjoyed this video. If you did, I'd love it if you could like the video and subscribe to the channel. If you like this content and you want to see more and help help me out as well, you can take a look at the Patreon or support me on YouTube memberships or through Super Thanks. And what we're going to do in the next video together is actually put this into some practice and get some exercise and hands-on experience with this, with some exercises. So I have a bunch of those prepared specifically for just routing, and we'll go through these different examples as well as URLPattern. And then following that, we're going to take a small detour into things on how to store data on our server. So we have an idea of some high-level concepts of data storage, like in memory, or databases and things like that, before we actually go to specific routes and we actually start building out things like a GET request and put request and all that kind of stuff, so we can actually get our full REST API actually working. This was super fun to put together, and I was so excited to share it with all of you. I'd love to hear kind of what you think in the comments below, but I will see you in those exercise videos.